We're starting problem number 3 with this new idea of the factor theorem. The factor theorem is really something that you guys already know. It's saying the expression x minus a is a factor of the polynomial if and only if the value a is a 0 of that polynomial. What does that mean? It means that whenever we're factoring and then we're solving, we would maybe have x plus 1 times x minus 2. I'm just making these up. Then we would solve that and say our zeros are negative 1 and positive 2. What the factor theorem is saying is that your expression, such as this x minus 2, that expression is a factor of our polynomial only if 2 is a 0 of the polynomial. You guys already know that. You take the factor, you find the 0. That's what this is saying. If we got a 0 of 2, then we know that came from x minus 2. We did this a little bit at the end of chapter 4 with our quadratics. So when we have a problem that says, what is the cubic polynomial in standard form with the zeros, negative 2, positive 2, and 3, we have to start by saying, what factors did those 3 zeros come from? What factor would the 0, negative 2, come from? How would we get negative 2 as an answer, Andy?
X plus 2.
Exactly. This 0 would give us x plus 2. That's the factor that it came from. How about our 0 of 2? What factor did 2 come from? Connor? Right. And Katie, what factor did 3 come from? Exactly. So we're working backwards. We're taking our zeros and then finding the factors. The question is asking, what's the cubic polynomial with these zeros? So once we have our factors, to go back to the polynomial, we just have to multiply them all together. So it's just FOIL, the distributive property. That's all we have to do. So I'm going to multiply these two together first to get x squared minus 2x plus 2x minus 4. That simplifies to x squared minus 4 times x minus 3. Just out of curiosity, how many of you do not write this step and just go straight to here? Do any of you do that? Okay, a couple of you do. Okay, it doesn't matter, I'm just curious. Okay, now we have two binomials again, so we just have to FOIL again. X cubed minus 3x squared check to make sure you can't combine any like terms. Check to make sure it's in standard form. All of those things are true. So this is my polynomial. Y equals x cubed minus 3x squared minus 4x plus 12. We worked backwards from the factoring. What is a quartic polynomial? So now we know that this is going to be a degree 4 polynomial because it's using the word quartic. We also know that we're going to have 4 zeros because there are 4 zeros right there, and also because it's quartic, that means we're going to get 4 zeros. So just look at your zeros and determine what factor did this 0 come from. Negative 2 came from a factor of x plus 2. We have another negative 2, which came from the factor x plus 2. The 0 of 2 came from x minus 2. And a 0 of 3 came from x minus 3. Now remember, multiplication is commutative, so that means you can reorder these sets of parentheses a little bit and multiply them in whatever way you want to. If you wanted to multiply these two together first, you can. If you want to multiply these two together first, you can. It's multiplication. You can multiply whatever quantities you want as long as at some point they're all getting multiplied together. So I'm just going to go from left to right. First, I'm multiplying x plus 2 times x plus 2. So we get x squared plus 4x plus 4. What do you guys think the easiest step would be next? It's not really a right or wrong answer, but if you were doing this without me, what would you guys multiply together next? What would you do, Ryan? With the trinomial? Okay, good. You can absolutely do that. So I'm going to multiply this guy through here. And remember, there's going to be a whole bunch of distribution there, okay? So we're ending up with combine your like terms. And then you just have to do your multiplication one more time and multiply that x minus 3 towards that whole 4-term polynomial. And after all of that multiplying and all of the combining of like terms, you finally end up with your quartic polynomial. Y equals x to the 4th minus x cubed minus 10x squared plus 4x plus 24. Now part C is asking you to graph both of these functions, and it's asking you how do they differ and how are they similar. You don't have to graph these by hand. You can go ahead and either use a graphing calculator or quick graph is probably easier for you guys because it's right there. So I want you to put both the problems from A and B into your graph, and we're going to go ahead and sketch them roughly right here for C. Graph A and graph B. Put those in and make a rough sketch of them. Remember, a turning point is the point on the graph where the graph switches from an increasing to a decreasing behavior, or vice versa. What about the end behaviors of the graph? What's the end behavior of each of these graphs? Go ahead, Connor. Right. So I'm going to abbreviate EB for end behavior of graph A is down and then up. The end behavior graph B is up and up. Why do these graphs have the same zeros, but one's a cubic and one's a quartic? Or why do these graphs have the same zeros, but they look different? These graphs have the same zeros, but what's different? Connor?
They both have a 4x term, but one's positive and one's negative.
Okay, that makes some of the difference. A positive and negative 4x, that'll make some of the difference. Focus on the zeros. Think about where we started these problems at. It told us these are your zeros, find the polynomial. And those zeros were the exact same. But the quartic polynomial had what? 2 negative 2's as a zero, right? Our quartic polynomial, the one in B, that's written in black up there, if you look back to its zeros, you see that negative 2 is repeated as a zero. That is why, right here at negative 2, it just touches the graph. It touches at this repeated zero. Whereas here, it's crossing at the zero. That's something we're going to get to in the next problem. So that is why, even though these have the exact same zeros, they're different graphs, because the zero of negative 2 is repeated twice in polynomial B. Let's try this again. This time we have what is a quadratic polynomial with the zeros 3 and negative 3. This one's good. We don't have to multiply quite as much. If our zeros are 3 and negative 3, what factors did that come from? If our zeros are 3 and negative 3, what factors did they come from? Ryan.
X minus 3 and x plus 3.
Right? Foil those. See how much less time that one took? That was a good one. There's our polynomial for part A. What's the cubic polynomial with zeros 3, 3, and negative 3? The factor that a zero of 3 comes from would be x minus 3. We have that factor of 3 repeated twice. So we have x minus 3, and x plus 3. Bless you. multiply through to get your next polynomial. And now it's saying in the C part of the question, graph both functions. How are the graphs different? How are they similar? So once you get both of your polynomials, go back to quick graph, graph both of those, and we'll compare similarities and differences. What are your similarities of these two graphs? Steve?
They have the same zeros.
Right. What are the differences of your graphs? Go ahead, Steve.
A only has one turning point and B has two.
Good. Got something else, Steve?
The end behavior on A is up, and on B is down.
Good. Is that what you're going to say, Catherine? Okay, good. And notice again, we've got the 0 at 3. Both graphs have that 0 of 3, but the way they cross 3 is different. Here in graph A, it crosses at positive 3, whereas in graph B, it more so just touches the graph or the axis at positive 3. So we have the same zeros, but we have a lot of differences.